Hello everyone, and welcome to my complete guide to Kubernetes in 2020. This is Brad from DevOps Journey, and let's get started. So just like all my courses, all the commands I run and all the code I use is available in the description below. Use the GitHub link and clone the directory. So I'm in GitHub right now, and I'm gonna grab the URL and I'm going to get this into my clipboard, and I'll pull up my terminal, and I have an empty spot here where I want to clone my directory. So I'll go get clone and right click, hit enter, and we can see that it's cloned my Kubernetes labs directory. And if I hop into that directory, I can see the configurations, lab volumes, and a Vagrant file. This directory is going to look a little different for everyone when they're following along, since I'm going to update these files and have everything that's required for all these videos. But to get started, I'm going to run this Vagrant file, and let's have a look at it in Visual Studio Code before I do. So I'll open up Visual Studio here, and having a look at the Vagrant file, you can see that I'm just bringing up a single host, and I'm calling this host Minikube. This is going to run our Kubernetes cluster. It's a requirement that it has 2 CPUs and 4 gigs of RAM should be enough for everything we're doing here. To get this started, I'll hop back into the terminal and I'll just go Vagrant up. So this is going to provision our Minikube cluster that we're going to use for all these labs. So if you're wondering what Vagrant is, I have a course available for you. It's a very short course, and you'll learn everything you need to do to get running and started with Vagrant. And Vagrant is just awesome if you're in the DevOps world and you need to provision new lab environments, development environments. You can just run a script and it will completely build a virtual machine for you. And we can see that it's doing this for me. I'm going to go ahead and speed this up, and I'll meet you guys on the other side. Alright, so it looks like my Vagrant virtual machine has provisioned here, and if I pull up VirtualBox, you can see that my Kubernetes virtual machine has been created and it's running. All these other ones are just virtual machines for other labs that I was doing. This is the one that I'm interested in right now. It's good to see that it's running. Let's SSH into that virtual machine and we will install Minikube. So if I just go Vagrant SSH, it's going to bring us into Minikube. And now we're in our virtual machine that's named Minikube. Let's go ahead and install Kubernetes Minikube. Alright, so the first thing I'm going to do is I'll clear my screen, and then I'm going to do an apt-get update. And this is going to update my apt repository to make sure when I go and get the Kubernetes, it's going to pull the latest packages. So I'll let this run. It'll take about a minute. I'll speed up the video. Alright, that looks like it's complete. So the next thing I'm going to do is install some pre-requirements that Kubernetes will need. These are the pre-requirements, so you can see that I'm doing an apt-get update. I have -y here to auto-accept any prompts that come up. And Docker IO is the most important one, because this is going to be our container services actually running all the containers, and Kubernetes is just going to be orchestrating with Docker. And there's a couple of other things that are pre-requirements to get everything working and to help test. So just download all these, they'll install, and you should be good to install Minikube after that. So I'll let this install complete, and then we'll install Kubernetes. Alright, so our pre-requirements have installed. The next thing we want to do is enable the Docker service to run. So I'm going to do that with a system control enable Docker service. And it looks like that went through successfully. So the next thing we want to do is download Minikube. And we're going to do that with this next command here. Let me clear the screen. Alright, so I'm just going to paste the command for downloading Minikube here. And you can see that it's just running a curl command, and it's grabbing it from Google. And then you can see on the next line, it is making sure that it has the executable permission. So I'll hit enter, and it'll download. And you can see that it was a pretty quick download. It was only 52 megs. And now I'm going to paste in this next command. So you can see that it's two commands chained together. The first command creates a directory, and the second command installs Minikube into that directory. Alright, so it looks like that installed properly. We got everything we need to for Minikube. The next thing we want to do is get it started. So we're going to do that with the Minikube command, the Minikube start command. And then we actually want to send the option --VM driver equals none. Alright, so the Minikube installation has completed. It took a few minutes. I sped up the video just to make it go quicker for everyone watching. So now that it's installed, let's check the status of Minikube just to make sure everything is functioning properly. So we'll do that with the Minikube status command. And we can see that everything is running. So kubelet's running, API service, and kubeconfig is running. So perfect, we have our Minikube cluster running. But Minikube isn't the only thing that we need. We actually need the Kubernetes client to interact with Kubernetes, send commands, check statuses on pods, and everything like that. So the next part of our installation is to install a tool called Kubectl. And I'm going to copy in the command for this. And remember, this is all available on GitHub. And you can see that it's doing the curl command as well, and it's grabbing it from Google. And yeah, it's just downloading and installing Kubectl and making sure that it's executable. So that looks like it's run properly. Let's clear the screen. And the next thing we want to do is we want to do kubectl version. And we can see that we got this version. Just make sure that if you're following along that you're running on a similar version or a version that's in the future. So the next thing that I really highly recommend, and this isn't just for Kubernetes, but with any application that you're installing for the first time, and you know you're going to be working with it a lot, you should create some aliases just to make your life easier. So I have two primary aliases that I'm going to be using in this course. So the first one's this, and I'm just mapping kubectl to sudo kubectl, and that's so you don't have to type sudo every time you run the command. It'll always run it with sudo in front. So I'll hit enter there. And now my second recommended alias that everyone should use is this. And I'm just mapping the letter K to sudo kubectl. So it makes it so I just need to press K and I can run any kubectl command. So we have those two aliases. Let's test them out. So if I do kubectl version, you need to type it correctly. We can see we're getting output. And if I do K version, it works just the same. So now instead of typing out the entire kubectl each time, I just need to type K. So I'm also going to create these aliases for Minikube. Although we're not going to be using Minikube commands that often, I just like having them there. So I'm going to go alias Minikube equals sudo Minikube. And now if I type Minikube status, I'll get a status without a warning that I don't have permissions. Perfect. So those are the three aliases that I always create in a lab environment to help you work with Kubernetes and Minikube. Alright, and just to show off our aliases again, we'll do alias grep I sudo. And you can see the three aliases that I created. And a little trick just to make these persistent is to throw them into our bash profile. So I will send the output of this command to home and then .bash rc. And now if we look at the last 10 lines of our bash profile, we can see that the alias is in there. And now if we close out our session and come back in, our aliases will still be there. They're persistent now. Alright, so now that we have kubectl installed and we got some aliases, let's start working with Kubernetes. So our first command is to gather some cluster information from Kubernetes. So I'm going to do that with kubectl cluster -info. And you can see it's gathered all the Kubernetes information. So you can see that it found the master node, and this is the location. So this is the IP address of the Minikube server, and it's listening on port 8443. And you can also see information in regards to Kube DNS. We'll go over Kube DNS in a later section and describe how Kubernetes has name resolution and how all the containers can communicate with DNS. And just to show off the alias, we could just do k cluster info and we would get the same information. Alright, so we have Minikube installed, we got Kubectl installed. Let's go ahead and get a deployment going, have a look at it, and just interact with it. I think it's the best way to get your head wrapped around Kubernetes is just to get a container up and sort of play around with it. So once we have that foundation built up, then we'll get into the nitty-gritty of explaining everything about pods and containers and the YAML files and getting everything working as infrastructure as code. Enough talk. I'm sure everyone just wants to get in there, get started. I agree. Let's get started because it's really simple to get a deployment up and running. So we'll start with the Kubectl commands and we'll do a deployment, and you can give it any name you want. I'm going to call mine Hello Minikube, and then I'm going to grab an image here. So you can just copy and paste what I have here. This is on my GitHub as well. And basically it's just grabbing an echo server from the K8's repository. And this is, oh, I misspelled deployment. Oh, I need the create command here. So kubectl create deployment. And basically this is an Nginx web server that will return information in regards to the container. So it's really good for testing things out in a lab environment, and just so you know that everything's running properly, and great for testing. So as you know, with web servers, they take in network traffic, and with network traffic you need to have a port open. So to do that in Kubernetes, you need to expose a port. So we'll do that with kubectl expose, and then we'll work on the deployment hello minikube. So I'll just copy and paste this, and then we need to give it a type. We'll just give it the type of node port, and again in a section later in this video I will go over the different types that you might want to use, but node port will work for us right now. And then we want to choose a port. I'm going to choose 8080, but feel free to use any port that you wish. And you can see that the service exposed the port. Perfect. So that's all we need to get started and have this container running within a pod, and the service has the port exposed. So the next thing we want to do is some verification commands just to make sure everything is running properly. So we'll start with the kubectl get command, and we want to get the pods. And here we can see the pod that we created. 1 of 1 is running, and it was just created about 2 minutes ago. Perfect. So that's what we want to see. Kubectl get pods is really useful for troubleshooting and getting information in regards to your pods. It's going to be one of the most used commands that you use when working with Kubernetes. So get familiar with it. The next one we're going to do is k or kubectl get service, and you just type svc, and you can see there's 2 services exposed here. This one's there by default, and then we have the hello minikube one that we created, and you can see it has that node port type, and it's giving you a cluster IP address and a port. So if you were to do curl this and then 8080, you can see that the web server is returning traffic. You can see it's giving the host name and a bunch of other stuff. So that's one way to do it, just by grabbing this cluster IP address. But a more proper way to do it is to find the service IP address that has actually been exposed. This will make it easier when you're coming in from the outside world to reach this service. So to do that, we will do Minikube service, and then the service name that we created, and we want to grab the URL that's been exposed. And as you can see, it's a different IP address and port pair. But if we do curl this, you can see, hey, it's working. So that looks good to me. So another thing that is commonly used is to look at the logs of the container, just so you have an idea of what's happening in that container. So if I was to type klogs hello minikube, you'll see that it doesn't return anything, and that's because we need to give the actual pod name. So let's do kget pods. Okay, this is the pod name. Let's get this in our clipboard. Now let's do klogs and hit that, and you can see, hey, we got, and you can see exactly what that container did. So it looks like it got a cert, wrote that cert there, started Nginx, and it's seen 2 HTTP GET requests from the curl command. So yeah, that's exactly what happened. So you can grab a lot of information using the kubectl logs command to get everything that's happened within a container. So that's a very common tool that you'll use. The next thing I'm going to do is just clean up what we have here. So if we do kget pods or kget service, you see that we have this hello minikube. So let's get rid of it. Let's get a clean environment going before we move forward with this video. So we'll do that with the kdelete command, and you can delete basically any Kubernetes object. The 2 Kubernetes objects that we're interested in are the pods and the services that we created. So let's delete the service first. So I'll do svc, and I'll go hello minikube. And you can see the service hello minikube was deleted. Let's rerun that, but we'll change it to deployment, and we'll go hello minikube. And the deployment has been deleted, and since the deployment is deleted, the pods should be gone. So if we do kget pods, you can see it's terminating. It's getting rid of those pods. And if you go kget service, you can see that the hello minikube service is no more. Rerun this. Yeah, it's still terminating. It'll take a few minutes, but eventually it'll be gone. Alright, so before we get into any more commands, I think it's really important that we have a good understanding of the base architecture of Kubernetes. So I have this diagram here, and this is the diagram that we're going to work with throughout this course, and we're going to build upon it as we get more complicated and add more concepts here. But just knowing this diagram is 90% of what you actually need to know and understand to work with Kubernetes. So this diagram is broken up into a few different pieces. As you can see, there's containers, and those containers are held within pods, and those pods are within a node, and those nodes are controlled by the master server, also known as the API server. So whenever we run the kubectl command, we're talking to the API server. And that API server is controlling which nodes see those commands and creates those resources. A node is just a worker machine in the Kubernetes cluster. It can be a virtual machine, a physical machine, anything. At the most basic level, it's just a Linux server running the Kubernetes service. And it's going to be providing all the compute and storage for our pods and containers. Containers are the same things as Docker containers, and if you're not familiar with Docker, I highly recommend watching some of my Docker videos where I go into detail exactly how containers work. And now that leaves us with just pods. As you can see here, each node can have multiple different pods, and those pods can hold containers. So I think the best way to think of a pod is it's a container of containers. And a really good example is just a simple web application. That web application probably has a front-end web server like Nginx, as well as a database server like MySQL. Each component would have its own container. So Nginx would be its own container, MySQL would be its own container, and then the pod would wrap those two containers together and make it so they have an environment where they can communicate with each other, as well as be able to manage that entire application stack easily through that pod. Anyways, that's all we really need to discuss for theory right now. Once we get in there and start showing the commands, all these concepts are going to make a lot more sense. So let's get back into the terminal and have a look at our nodes. So to get information in regards to the node, just do kubectl get node. And you can see that it returned one node, and the node was Minikube. Now if you were working with a full production Kubernetes environment, you would likely have more than one node. Minikube is a single node cluster just to get you up and running and test out Kubernetes. So seeing just one node here is fine, but if you did have a full-on Kubernetes environment with multiple nodes, you would just get the same information, and you would just have multiple nodes, and they would have different roles here. Now you can run the same command if you want to get more information, and just do get nodes and add the wide format. So the -o is used for formatting, and we want the wide format, and this gives us a lot more information. We can see it's giving us the IP address, the actual OS image that's running on there, the kernel version, and the container runtime, so the Docker version. So some good troubleshooting information there in regards to your nodes. The next thing I want to go over is the Kubernetes describe command. So this describe command can be used on any Kubernetes resource. We'll use it here on the node to give us more information in regards to the node. But you can use this for pods, services, deployments, whatever. So we'll just do describe node, and you can see that it gives a lot of information. And just scrolling up, I'll just go through this information quickly. You can see, yeah, the name's Minikube. It's got these roles, all these labels, annotations, which we're obviously going to go through in the later section. But you can see basically any information in regards to the server you can get with the describe command. Okay, so we'll clear the screen. The next thing that's also available in most of the commands is if you do get node, and if you do that -o parameter again, but let's put YAML. This is going to provide us what the YAML file will look like for this node. And yep, you can see it returned a lot of information, and just scrolling up, it's basically the same information that we got from that describe command, but now it's in YAML format. And when things are in YAML format, that means you have infrastructure as code. This makes it reusable. You can make sure that your other environments match this exactly. So very useful command. Not as useful for the nodes, but when we get into deployments and services and pods, having it in YAML format is the preferred way, because that lets you use things like source control to manage all your changes, and it's just a good practice. So we have that. If I rerun this command and I change -o, I can change it to JSON, and we can see, hey, we got the same information, but now it's in JSON format. So whatever your preferred format is, you can get the information. And that's all we really need to know for now in regards to nodes. Let's get into pods now. So if we start with kubectl get pods, we can see that there are currently no pods in the default namespace. So you might be wondering, what's a namespace? And we'll get into namespaces a little bit later, but basically all you really need to understand about them is they're a way of segmenting Kubernetes resources from each other. So to have a quick look, let's do k-get-ns, and this is going to return all the namespaces. So by default, we have these 4 different namespaces. These ones are used for doing like behind the scenes Kubernetes stuff. And then the default one is what all our pods are going to fall into when we create a deployment and don't assign it its own namespace. So by default, when you do kubectl get pods, it just looks in the default namespace. And since we don't have any active pods, it doesn't find anything. But if I were to rerun this command, and if I go -n and I provide the namespace of kubesystem, you can see we have a bunch of pods running. And these are all just for the behind the scenes Kubernetes stuff. So you can see like there's an API server, it's got the controller, it's got a scheduler, a storage provisioner. So lots of behind the scenes stuff that we'll get into later. But it's just good to know that's how you look at pods in different namespaces. So I'm actually going to get a pod up and running here, just so we have something to look at in the default namespace. So I'm going to rerun this create deployment command, and it's creating that hello minikube echo server. Now when I do k-get pod, you can see that we got a pod and it's running here. Perfect. So let's go over the rest of the pod commands. So very similar to how the node commands worked. So if we do k-get pod and we want to change the formatting, we could go -o and we could do wide. And as you can see, it gives us additional information in the terminal. If we take that -o but change wide and we change it to YAML, you can see it returns all the output of the pod in a YAML file. So we could actually take this file, upload it to a completely different Kubernetes infrastructure, and it would run this exact same pod in the exact same environment. So this is exactly what they mean when they say infrastructure as code. Now you can see that it's got a lot of lines of input here and a lot of different things, and everyone's probably like, oh my god, this must be a very complicated thing to bring up. It's actually not. If I were to create a YAML file from scratch to get this pod up, it would actually only be a few lines of code. And we're going to do that in a few minutes here, because I think it's important to see just how easy it is to get a pod up using a YAML file. But before we do that, let's have a look at the rest of the pod commands. So just like all Kubernetes resources, you can use the describe command and just do k-describe pod. And you can see it gives all the information in regards to the pod. So again, a very good command to get any information you need. The next very important thing to know is how to get labels for the pods. So we just do that with k-get pod and then do -- show labels. And you'll want to save this command, have it ready in a notepad because you're going to be using it a lot. We'll get into labels a bit later, but just to show them off right now, you can see that every pod will have some sort of label on them. And Kubernetes has a lot of different logic on what it can do based on these labels. And we're going to get into how we can control the whole flow of our Kubernetes infrastructure using these labels. Okay, so the next thing we're going to do is we're going to use a YAML file to create a pod. But before we do that, let's get rid of the current pod that we have. So we'll do that by doing k-get pod and then k-delete pod, and then we'll paste in the name. And you can see that it's deleting. I'm going to hop into my code editor and we're going to have a look at the YAML file that we're going to create here. Alright, so I'm in my IDE environment. I'm using Visual Studio Code. If you clone the GitHub repository that's in the description below, you will have all these files available to you. Might look a little different on your system because I'm going to be making a lot of changes before this course is done, but it should look somewhat similar to this. So I have a configs directory here, and I'm going to open this one called mypod.yaml. So this is the YAML file that Kubernetes is going to read to create our pod. So as you can see, it's very simple, especially when you compare it to that command that we just ran previously, which was kgetpod, and then we did the -o YAML, and it returned what looked like 100 lines of code with a bunch of information in it. Yeah, you don't actually need that much information just to get a simple pod up and running. More often than not, your pod files will look something like this, with just a few lines of configuration. And let's go ahead and read this just so it makes a little more sense. Alright, so this first line is very important. As you know, Kubernetes runs through an API. All the commands we send to it go through an API. And basically what this line allows is backwards compatibility with your Kubernetes infrastructure, right? So if you're running on Kubernetes version 500 or whatever in the future, as long as you specify in your API file that, hey, this file was built for version 1 of the API, it's going to work. So it's very important for backwards compatibility. So in later sections of this video, you'll notice that this API version, it's changing. That's fine. Just make sure that it's exactly the same to what I have in my file, and you should get the same exact results on your system. So this second line here is labeled kind, and this is just telling Kubernetes what type of resource this is. So this could be pods, this could be namespaces, this could be services, this could be deployments. This is basically just telling Kubernetes what type of resource this is so it knows what it's building. So this is a very important line as well. So next is the metadata, which is data about data. And you can see that we're giving it the name of my pod, and then we're adding in labels. So I've got a label here called app, and I'm saying this is my test app, and the environment is dev. So these are strictly labels. So my application has two labels. So one example we're going to show off is if we want to filter all the pods that have the label environment of dev, we can filter all the pods that have the environment of dev, as well as production, test, whatever you want to name it. This is up to you to be creative and give your pods labels that make sense. Alright, so next we have the spec, and this is the specs of the containers. We have this node selector section. I'm going to take this out for now, and we're going to add it in later. Basically, this is used to choose which Kubernetes nodes the pod will run on. So I'll take this out for now. Okay, so we have that taken out. So now you can see you can have a list of containers. So each pod can have multiple containers with it. In this specific example, it's a single container within the pod. And the name we're giving it is Echo Server. It's got these ports open, and it's using this image. So it's a pretty simple environment here. I got the file saved. I'm actually going to rename it, add a 1 here. So it's called mypod1.yaml. Let's hop onto our terminal and get the pod created. So I'm back on the terminal here, and now if I do a kgetpods, I can see that my other pod did not delete, and I know why. It's because I actually needed to delete the deployment. So this is a good example of how Kubernetes works. Pods are self-healing. That means that if you delete a pod, it's going to come back, right? As long as that deployment exists, the pod is going to try to recreate and recreate and recreate. So how do we fix this? We delete the deployment. Let's go get deployments. Okay, we got the hello Minikube deployment. Let's go delete deployments. I'll paste in this name. And we can see the deployment is deleted, and now the Kubernetes controller is going to see that that deployment's deleted, and it's going to go, hey, we don't need this pod anymore, get rid of it. So let's see if it's doing that. We'll do a kget pod, and we can see it's terminating. So that's good. It should be gone soon. Now let's go look for those YAML files that I have created. So I'm on my Vagrant machine, so everything should be in a folder called /Vagrant. If I do an ls, I can see my directories if I go into configs. And this is the full path to the directory that I'm working in. And if I do ls mypod1, I can see we have that mypod YAML file. And if I look at it, yep, this is the one that we were working with. So let's get a pod created based on this YAML file. Alright, I needed to clear my screen to make up a little room here. Let's have a look at the kubectl create command now. So if I go kubectl create, I want to do -f to specify that file. And now I do mypod1.yaml. So as you can see in this command, I didn't specify that it was a pod or what type of resource it was. It's just the create command, and you specify the file. And within that file, it has the type defined. So that's how it knows to create a pod. So let's hit enter and watch this pod get created. So we can see the pod is created. Perfect. Now if we do kget pods, we can see my pod is running. And if we wanted more details, we could go kget pod and do the format of wide. Little more details, but that's not exactly what we wanted. What if we did show labels? Yes. So we have the two labels that we created, test app and the environment of dev. Now what if we wanted to make changes? Would you want to delete the pod or would you want to update it? I think it's better to update it, so let's have a look at how we can do that. Alright, so let's make a change to this configuration file, and we'll just keep our change really easy here. We'll change test app to my app, and that's good enough just to test what we want to do here. And I'm going to go into the command history and look at this create command, but instead of running create, I want to apply a change. So I'm reapplying this file. And there was some warning, but I'm not going to worry about that. But we can see the output here was my pod was configured. So if we do kget pod, we can see, yep, it's been running for 3 minutes. But now if we do the show labels, we can see that the label name has changed from test app to my app. So we are able to change the YAML file and apply that change very easily with just one command. Alright, so that's a good brief understanding of the YAML file and creating a pod. Let's do one more change that will give us a better idea of how we can use labels. So I'm going to hop back into my code editor here, and I'm going to copy this file, and I'll just create a new one. And let's rename it to mypod2. And I'm going to keep everything the same, but I'm going to add in under spec what I took out before, which was node selector. So we'll go node selector, and then we want to select the node based on this label, dev. So basically what this means is it's going to try to start this pod on nodes that have the label of environment with the value of dev. So if I had some nodes with the label environment production, it's not going to start on those ones. It's only going to start it on the nodes that have the label of environment dev. So let's apply this change to our pod, and we'll do a kubectl apply, and we'll do -f mypod2.yaml. And make sure to specify 2 and not 1. We want to use the new file that we just created. And we can see that we got an error here, and the error is forbidden. The pod update can't change this field. So basically what it's saying is you can't update this specific field that you want, the node selector. You're going to have to recreate the pod. So let's do that. Do kget pods, k delete pods, my pod, and we can see that it's deleting. It will probably take about a minute here. So I'm just going to let this complete. Alright, looks like it's completed. Do kget pods. Perfect, no pods exist. Let's go back into the command history, and instead of apply, we have to go create. So we'll do kubectl create mypod2. And we can see that it's created. But what happens if we do kget pods? We can see my pod is there, but 0 of 1 is ready. Status is pending. So what exactly is happening here? It's just stuck on pending. And basically, it's because of that change we made, which was adding the node selector. We're saying to only run on nodes that have the label environment dev. Well, let's have a look at our nodes. So we'll do a kget nodes, and we can see we're running on a single node cluster here on Minikube. Let's look at the labels on this node. So we'll just do the same, but add show-labels. So we can see there's a bunch of labels here, but none of them look like they are what I want. None of them specify an environment. So right now, this Kubernetes node doesn't have the environment set to production or development. We could further check to see if this node has labels if we do kget node-l and specify the label. And we can see it returns all the nodes and the environment label for those nodes, and you can see that Minikube has no value there. So let's give this node a label. So it's very simple to do that. We'll just do k-label, and we'll specify the resource to be node, and then it wants a node name, so we'll name it Minikube, which is right here, and let's give it, and let's set env equals dev. Now we can see that the node Minikube has been labeled. If we rerun this, we can see, hey, Minikube now has the environment labeled dev. Now let's check our pod. So we'll do a kget pods, and look at that, my pod is now running. So another powerful tool available to us when working with pods is being able to run a command on a pod or open a bash shell. So the way to do this is very similar to the way you do it in Docker, and that is to pull up kubectl, and then you use exec. And then you specify the pod name, so I'll specify my pod, and after that you do 2 double dashes, and then after those double dashes you can specify your command. So let's do an echo hello world. You can see it comes back hello world. That was the output of the pod. If I were to go up, change this, and do hostname, it's going to return the hostname of the container in that pod. And you can see it returned my pod. Now that's good for just running one-off commands in an ad hoc style, but if you want to hop into the shell of the pod, try this. You do kubectl exec-it, specify the pod name, and then just pull up a bash shell. And you can see we are now in the pod, and if we do hostname, we get my pod, date, it returns the date. So we're in the pod. You can do anything in that pod that you want. So really good for troubleshooting. I'm going to exit out of here. And if we do k get pods, you can see the pod is still running. Alright, now that we understand what labels are and how we can use them, let's get into all the commands available to us for labels. So we'll quickly review some of the commands that we already know. So if we do k get pod show dash labels, we get all the pods back and we can see which labels are attached to them. And this parameter is available to us no matter which command we use. So if I change pod to node, it'll return us the nodes and all the labels available there. The next thing is, if we go k get pod, if we do -l, we can actually specify the label. So we see that returns all the pods and gives the env label. If we do this and then we do another label of app, because we have app defined, we can see, hey, it shows both. We can also add a bit of logic when we try to get labels. So if we do k get pod, but this time instead of a capital L, if we do a lowercase l, we can go env equals dev. And you can see that returned my pod. And let's add the parameter show labels here, just so you can see, yes, env equals dev there, so that's why it matched. And if we said env equals prod, then we would see that it doesn't find any pods. Also, you can negate things. So we could say where the environment isn't equal to prod, and you see it returns my pod, and change that to dev. It doesn't find it since the name is dev and the exclamation point is negating it. So lots of different logic you can use that will help you filter things based on their labels. We can also get a little more advanced with our label selectors. And to do that, we would just do k get pod -l, and we could go, we need it in quotations here. We just go env in, and then we can provide a list. And we'll just say prod or dev. And need to end that. Perfect, so we'll return that. And I keep hitting the up arrow. But if dev wasn't in there, it just said prod, then it wouldn't find it. You could go prod test dev. So, very powerful. And you could also go not in. And you see that return nothing. If I take dev out of there, it should return it. Yeah. So lots of different options with the logic you can use. Another thing is if you wanted to add a label on the fly to anything, you would just go k label and then specify the resource. So we're going to specify the pod here, and we'll say my pod. And you know what? Let's change it to production. And if you want to overwrite it, then you have to specify overwrite. And you can see that it was changed. If I do k get pods show labels, you can see environment is production. And if I take one of these here, let's say it's in prod, you can see it returns. Another thing you can do is use labels to filter on other commands. So if we do k get pods show labels again, our current label is env equals production. Now if I wanted to delete all the pods that have the label production, I would just do k delete pod, and we'll go l environment equal dev. We'll see no resources found. How about if we change this to not equals dev, and you can see it found this one, my pod, where environment equals production, and it's deleting it. So that's everything we need to know about labels for now. Next, we're going to get into annotations, and annotations are just a simple way that we can add a comment to a Kubernetes resource like a node or a pod or deployment. So let's go ahead and get our pod started again, and we'll add an annotation to it. So to get the pod up and running again, I'm going to do a kubectl create -f, and then I'll reuse that same YAML file. Hit enter, and the pod has been recreated. And now if I want to see if there's any comments or annotations on this resource, I would just do a kubectl, or I'll just do K because I got the alias up, and then I'll do a describe. And I can't type tonight. And I'll do a pod, my pod here. And you can see that the annotations is set to none. So let's add an annotation here. We'll just go K, annotate, pod, my pod. And we'll give it the annotation of notes equals this is my first pod for testing Kubernetes. Hit enter. Now when I do K describe pod, my pod, I will see that annotation there. And you can basically add any amount of annotations that you want. So maybe I'll just give it an annotation of app type. I'll just go web server. And I go describe the pod again. And yeah, you can see that the app type is there now. There's a note section. So it's very flexible with how you annotate your resources. And if I wanted to annotate a server or a node or anything like that, I could just do the same thing. So K annotate node, and then I think I need to put in the node name, which is going to be the host name. So we'll do Minikube, and then we want that annotation here. So I'll just say server type, and then I'll say something like virtual Linux run created from Vagrant. There you go. Feel free to use any annotation that you like. This is your chance to be creative as a DevOps specialist. But now that annotation is created, let's do K describe node, and then we'll say Minikube. And if we scroll up, we can see the annotation is there somewhere in here. Server type, virtual Linux created from Vagrant, and then it looks like there's a couple default ones that are in there. So it's a good feature to have, very simple to use, good thing to understand. That's all we really need to describe about annotations for now. Okay, so the next thing we're going to get into is Kubernetes namespaces. And basically what namespaces do is they provide a way to divide up cluster resources between different users or systems. In most cases, in your own environments, you won't need them, but they're a good thing to know in case you run into them in the wild. So let's get into it. It'll only take a few minutes to go over. So your first command here when working with namespaces is going to be get ns. And this will return all the namespaces, and I showed this earlier in the video, but basically default is where all your pods and resources are going to end up if you don't specify a namespace. And then there's a few other namespaces like these ones, these system ones, and the dashboard, and basically this is what Minikube and Kubernetes is using to run the system. So just leave those ones as is. Let's go ahead though and create our own namespace, and we will assign a pod to a different namespace. So to do that, I'm going to hop into my code editor, and I have a new file here named custom-namespace.yaml. If you're on my GitHub, you can pull that file off of there, or you can just follow along and we'll fill out this file together. It's only a few lines here and it's very simple, and it's great practice to learn the syntax. So we're going to start out by giving the API version. And again, what this is the Kubernetes API that we're using. I'm going to use version 1 for the API since version 1 has everything we need for namespaces. The next line I'm going to do is kind, and kind is what the resource type is. So this is where you would put a node or a pod or whatever, but since this is a namespace, we're going to put namespace in there. And then we're going to add some metadata. And within that metadata, we're going to add a name. So make sure to indent. And I'm just going to call mine custom namespace because I'm not a very creative person. But that's it. That's all we need in our file. So you can see that it's backspace here, and that's only 4 lines of code, and we can create our own namespace, and everything will be saved in a YAML file in code, so we can bring this to any Kubernetes system and they could create the same namespace. So let's hop into the terminal again. Alright, so we're back here in our terminal, and since we have a YAML file, we're going to use the kubectl create command to create this resource. So I'll do that by typing k, since I have an alias set to kubectl, and I will do k create -f to specify a file, and I think I called it custom-namespace. Oops, I put customer there. That's why my computer is beeping at me. We'll go ahead and create that, and you can see that the namespace was created. Now when I do k get namespace, I can see the custom namespace has been created. But it would be kind of silly just to leave it like that. Let's go ahead and create a second pod here and assign it to this custom namespace. So to create this new pod attached to this new namespace, we're going to follow best practices and create the pod using a YAML file. So I've taken mypod1.yaml and I've put it into this new file named mypod-custom-namespace.yaml. And you can see it's just a basic setup here, but we're going to add one additional change, and that is adding that custom namespace that we just created. So to do that in a pod, it's actually under this metadata field, and we just add another attribute here, and we name it namespace, and we give that namespace a name. So I'll just give it the same name, and I keep calling it customer namespace for some reason, but let's call it custom namespace. And I believe that matches what we created. Yeah, custom-namespace. So they matched. So they match. Perfect. This is all saved up. Let's hop into the command line and create this pod using this YAML file. So we're back in the terminal. If we go cat mypod-custom namespace, we can see, yeah, that file exists, and this is the one we just created. So if we go k create -f and put that in there, it should create that new pod. And let's have a look. If we do k get pods, we see my pod here, but this is actually not the same pod. This is the pod that we've had running in the default namespace for a while here. So to show that, we can actually do k get pods -n custom namespace. This is the new pod that we just created. It's only been around for 59 seconds, whereas this one's been around for 46 minutes. So we know these two pods are different. Another good way to look at this, let me clear my screen to get more space. Clear that again. So if you wanted to see all pods in all namespaces, you could just go k get pods and then add the special parameter --all -namespaces, and this will return every single pod and let you know which namespace it's in. So we can see all those kube system ones, we can see the default one, my pod, and then we can see custom namespace here. Alright, so I wanted to quickly jump back into the theory, pull up this diagram that we've been using from before. I've made one big change to it, and that is adding a replication set. Now, all a replication set really does is it makes sure a certain number of pods are running. So, in this example, this replication set is set up for pod A, and it's making sure that at least 3 replicas exist. And within those 2 nodes in our cluster, you can see that pod A has 3 occurrences here. We got pod A1, pod A2, and then pod A3, and it's distributed around the cluster. Kubernetes does that all in the back end. You don't need to manually specify anything if you don't want to, although you can using labels if you need to get specific. But as you can see, it's a very simple concept. You create a replication set. That replication set has a pod assigned to it and a certain number of replicas that pod should have, and then it just goes out throughout the Kubernetes cluster and makes sure that all those replicas exist. So very simple. We're going to hop into the code editor and make a YAML file to create a replication set. But before that, we're going to create a replication controller, which is basically the same thing as a replication set, but it's the older way of doing it. It doesn't have as many of the newer features that replication sets have, but likely if you're working with Kubernetes on an older deployment, you'll run into them, so they're good to know. So we'll start off with a replication controller, create an environment similar to what we have in this diagram. Then we'll delete it, then we'll create a replica set, and yeah, you'll see at the basic level they work basically the same, and then we'll get into the extra features that replication sets have as we get deeper and deeper into this course. So let's go ahead and get started. Alright, so we're in our Visual Studio Code, and we have the mypod-rc.yaml file open, and this is all we need for our baseline replication controller that we're going to create. You can see it's very similar to all the YAML files that we've created with a few additional details. So at the top here, API version, you'll notice V1 since replication controllers came out with the original release of Kubernetes. V1 of the API will work. When we get into replication sets, we're actually going to have to change this value for the first time. So that'll be exciting, but V1 for now will work. And sorry about that pop-up, but moving on, we have the metadata, which we're just giving a name for the replication controller as well as the pods. And then we get into the spec, and in the spec you can see this new line that you haven't seen before, and that is setting the amount of replicas. So we're setting the replicas to 3. This means that the replication controller is going to talk to the Kubernetes cluster and monitor it and make sure that 3 pods are always running within the cluster. The next thing we have is a selector, and again we went over this in the label section, so if you need a refresher of how the selector works, please go into the description below and look for the timestamp for labels. In there, that's where we use the selector. But just a brief summary, basically the selector will look for a node that has the app label set to my pod, and that'll allow it to start this pod. The next thing is the template, and this is the template for the pod itself, and there you can see we have some labels set, and then the container configuration. This is a single container pod, so we just have the single container name and image, and it's that echo server we've been using. So this is a pretty basic replica set. Let's go ahead and have it created. So I'm back in my terminal here. I'm going to do a kget pods, and you can see that we have this original pod that we've been working with. Let's go ahead and create our replication controller now, and we should see 3 additional pods get spawned. So I'll do that with the kcreate-f, and I'll do mypod-rc.yaml, hit enter. We can see replication controller / myreplicated pod was created. So if we do kget-rc, we can see that we have a replication controller now, and we got a few columns here, and we can see they're set to 3, 3, and 3. And just to give a quick explanation for them, it's desiring at least 3 pods running, And currently there are 3 pods running in the ready state, so the replication controller is very happy. And just to prove that 3 are running, we'll do a kget pods, and we can see that there are 3 additional pods here, and they have the name my replicated pod. And to make the name unique, it's actually appended a unique string here. So that's perfect. That's how easy it is to get a replication controller running and monitor your pods. There isn't much more work than what we were doing to just create when we were creating the pods from scratch without a replication controller. So as you can see, you should always use a replication controller or replication set. And now, just to test out this replication set, we should try killing one of these pods and see what happens. So to do that, we can go kdelete, and then we can specify that we want to delete a pod. And I'm going to copy and paste this first one here. And you can see that it is trying to delete it. I'm going to hop on over to another terminal because it's going to take about a minute here. If I do kget pods, we can see that this one's terminating. And it looks like these other 3 are running. So it looks like if we do kget rc, yeah, 3 of 3 are running. So it's already started a new pod while this first one's terminating. And if we do kget pods again, we can see that it's still terminating. It'll take a minute or 2 to terminate. And as you can see, as soon as we terminated that pod, a new one came up almost instantly. So yeah. So that just shows you how good replication controllers are and why you should use them. But now, since we don't want to use replication controllers anymore, since they're the older style of doing it, let's go ahead and delete this replication controller and then create a replication set instead. So to do that, we'll just do kdelete rc, and the name was my replicated pod. And we can see that the replication controller is being deleted. And if we do kget rc, it's no longer there. And if we do kget pods, we can see all the pods are terminating since they're tied to that replication controller that no longer exists. Perfect. So we'll let those terminate. We'll hop back into Visual Studio Code and we'll create a replication set. Alright, so I'm back in Visual Studio Code, and I have a new YAML file open, mypod-replicaset.yaml, and it's basically the same thing as my replication controller YAML file, but there's 2 main changes here, and it's with the first 2 lines. So line 2, the kind, I've changed replication controller to replication set. And then line 1 for the API version, it's using a different version of the API. It's using the apps/v1 version of the API. So with newer versions of the API, Kubernetes has split things into different modules. This uses the apps module, so we need to specify apps/v1 in order to use replica sets. So this file is very simple if you already understand replication controllers, which we've just went over. So let's hop into the terminal again and get this running. So back in the terminal, if I do kget pods, we just have the one pod running. If we go kget rs, there's no replication sets created yet, so let's go create. So let's go kcreate -f, and then we'll do my pod-replica set. I think that's what I called it. Let me double check. Yes, that is what I called it, but I'm in the wrong directory here. So let me copy that. And then I'm going to go cd vagrant configs. Alright, and now I'll paste it. I wasn't in the right directory to find this file, so now I can find it. mypod-replicaset.yaml. I will hit enter, and there is a configuration error in my YAML file. So let's troubleshoot that together. And in the output here, it does give us a clue. It says unknown field app in the label selector. Okay. So let's have a look for the line indicating that. Alright, so I'm back in the code editor here, and I have my YAML file open. So this one looks exactly the same as my replication controller, but for some reason the replica set doesn't like this line. And I've had a look at the Kubernetes documentation, and that's because of the new features that they're adding to this. You can't just use a selector and then throw in a label there. You actually need to say, whoops, you actually need to specify to match labels. And the reason behind that is because with replication sets, they've added a lot more logic to this, so you need to be more specific. So we'll do the match labels, and I'm just going to indent this, and that should work now. So this is saved. Let's hop back into the terminal, and let's rerun the command. And it looks like the replica set was created. So if we do a kget rs, we can see that the replication set was created. It's desiring 3, and there's currently 3. Let's refresh that, and they're ready now. They weren't ready when I first ran the command, but now it's good. Now if we do a kget pods, we should see 3 of them running, and we do. So it's that simple. And just to show you that replication sets work the same as replication controllers, if I were to delete one of these pods, if I were to delete one of these pods, I would need to specify pod. There, we'll specify that, and it should be deleting. And if I hop on over to this terminal, clear the screen, do kget pods, I can see, yes, it's terminating that one and it started a new one. So that's good. Everything's working. So now you understand replication controllers, and then you saw replication set and saw that the replication set was very similar to how the replication controller worked, but it had that additional syntax that we needed to add in there for match labels. Now we'll go and get more advanced into that later on in the course, using those features to match more specific labels. But for now, all you really need to know is you should be using replication sets. So that's all we have to show for replication sets for now. We're going to move on to daemon sets, which are very similar to replica sets, but instead of making sure a certain amount of replicas exists, it's going to make sure a pod exists on each node that meets a specific criteria. So an example might be if you have a pod that monitors local system resources, like it makes sure that the CPU threshold is at a certain point, you would want that running on every single node in your infrastructure. So for that, we make a daemon set. Alright, so I'm back in my code editor here, and we have an example daemon set that we're going to create here. And this one is going to pretend to do some SSD monitoring. So if you had a bunch of nodes there, and you wanted to make sure that each of the nodes that had an SSD instead of regular hard drives installed, you wanted to make sure that they ran this pod that does some SSD monitoring. So what you would do is you would create a daemon set, and then you would make a container that has an image that runs the process of monitoring the SSD. But then you would also make sure that you have this node selector in here. And that node selector is going to look for the label disk and make sure that that label is set to SSD. Now, currently, our node does not have this label set. The disk label is not set to anything. It's not set to SSD or HDD or whatever. So when we bring up this daemon set, we're going to notice that the pod doesn't get created until we make a change and add the disk label. So let's go ahead and do this. I'm going to hop into the terminal and we'll get this daemon set created. Alright, so I'm back into my terminal here, and I'm just going to do a kget pods. And we can see that those 4 pods are still running. We have the default one that we created by itself, and then we have the replication set that's making sure that 3 are running. Let's get our daemon set created now to do that SSD monitoring. So to do that, we're going to do a kcreate, and we're going to specify the file, and I have it named as just daemon set. I'll hit enter, and we'll see that the daemon set has been created. Now if we do kgetpods, we'll see that there's been no change. Let's run the command kgetds, and this will return all our daemon sets. And you can see how it's configured here, and that should make it pretty obvious as to why no pods have been started. You can see that the desired is 0, and that's because it's using a node selector. And that node selector is saying the disk label needs to be set to SSD. Since we don't have any nodes that has this label set, the daemon set sees that none of these nodes should be running this pod. Let's go ahead and change that by setting this label on our node. So if we do kgetnodes and then specify show-labels, we'll see that we get a bunch of labels here, but I don't think I see the disk. Let's be a little more specific and do -L and say disk. And we can see that our node Minikube doesn't have any value set for disk. So let's go ahead and set that label for this node. So we're going to run the command klabel node, and then we're going to specify the node name, which is Minikube in our case, and then we're going to set disk equals SSD, and we can see that node/Minikube has been labeled. Let's go ahead and check on our daemon set now. So kgetds, and we see that the desired and current and all those values went from 0 up to 1. So that means the daemon set noticed that the node now has that label and it should be starting that pod. Now if we do kgetpods, we can see that the SSD monitor is running. So that's perfect. So all our nodes that have SSDs, all we would need to do as administrators is go ahead and set a label on that node, and now this pod will start on that node. Now just for an example here, say you didn't want this node to run this daemon set because it had a regular hard drive. So all you would have to do is label this node again but change the value. So let me copy and paste this command here. So we'll say disk equals HDD, and you can't just change the label without overwriting it. So let's overwrite, and we can see that the label has changed. If we do knode -L disk, if we can see that that command does not work. Let's try kgetnode-L disk, and yeah, it's set to HDD now. So that daemon set should not be running. So if we do kgetds, we can see the desired and count all went down. And if we do kgetpod, that pod's no longer running. So the daemon set is doing its job. It's checking nodes for this label to be set to SSD. If it's set to any other value, it's going to not start that pod. So that's all you really need to know for daemon sets for now. I hope that gives you a good idea. I'm going to go ahead and switch that label back to SSD, just so we have another pod running. I'll make sure to overwrite again. And now I'll do a kgetpod. You can see it's creating it right now, and it's running. So that's all we're going to show for daemon sets now. Let's get into jobs and then cron jobs. Alright, so the next concept we're going to get into here is jobs. And there's 3 types of jobs that we're going to go over. We're going to go over the regular batch job. We're going to do a multi-batch job. And that's basically the same thing as a job, but you can do multiple of them in parallel. And then we're going to look at scheduled jobs or cron jobs. So looking at this, I have a YAML file open just called job.yaml. And you can see it's very similar to the other templates that we've worked with. But at the top here, we are using a different API version. It's using the batch module in the API and version 1. And the kind of resource this is a job. And then I have the basics in here. I have a metadata and then the name under the metadata. And then beneath the template, this is the actual pod template. And you can see I've given it a label of app with the value of batch job, and the image it's using is batch job. So this is just to simulate a batch job. This would be if you have like a one-off job that just needs to run, and it just needs to run a pod for a bit. Maybe it's going to do some calculations, some machine learning or something like that, and it just needs to really run once. And the whole idea here is it just runs a pod, and it runs that pod until the job is completed. You can see I have a restart policy here called on failure. So if the pod runs into problems and errors out, it's going to restart it and retry that job. So let's go ahead and get this object created and play around with it. It'll make a lot more sense once we're in the terminal. Alright, so I'm back in the terminal here, and I'm going to do a k create -f, and I will create that job. We can see that the job has been created, and if I do a k get jobs, we can see that the batch job exists and it's been completed 0 of 1 times. Let's see if we can see the pod that this has created though. So if we do k get pods, we can see that the batch job has been created and it's still running. Now this job is going to take a few minutes to complete. It's configured like that. I'm going to let this run in the back end, but while that's running, let's go ahead and see if we can monitor it. So to do that, I'm going to do a k logs, and then I'm going to specify the pod name. And I'll hit enter, and you can see that the batch job is running. If I do an F, it's going to follow it. And then once the batch job is done running, it should say it's complete or something. And then once I see that message, I am going to check to make sure that the job has completed properly and that the pod has successfully terminated. So I'm just going to leave this running for a few minutes, and I'll see you guys soon. Alright, so it looks like our batch job has completed. It took 2 minutes here exactly, so you should see the same on your system as long as you are pulling down that image. So let's check out the status of our job now on Kubernetes. So I'll just do a k get jobs, and you can see that batch job has completed 1 of 1 times. And if we do a k get pods, we can see that the pod is 0 of 1. That means it is not running, and the status is completed. So that's a regular job. Let's hop into the code editor and have a look at a multiprocessed job. So if I pop this open and I go to multi-job, you can see that it's very similar to the YAML file that I had created, but I've added in 2 additional parameters here. You can see that I've increased the completions to 5 and the parallelism to 2. So basically what this means is it can run 2 jobs at once, and it needs to complete 5 times before it considers everything done. So let's go ahead and run this multi-job. So I'll clear the screen, and we'll do a k create -f, and we'll do multi-job. Hit enter, and if we do a k get jobs, you can see that there's a multi-batch job running. And if we do k get pods, we can see that 2 pods were created because 2 can be running at once. And this is going to take a little bit longer since it needs to complete 5 times. And we only have 2 pods running this job at once. So I'm going to leave this, and we're going to check on this in a few minutes here. Alright, I paused the video for a few minutes. I'm going to check on the status of this job. And we can see that it's been through 2 of 5 completions. If we do a k get pods, we can see that 2 of these multi-batch jobs have completed and 2 more have started. So I'll leave this for a few more minutes and we'll come back and everything should be done. Alright, so checking back here, I think everything should be about done. So if we do k get jobs, we can see 5 of 5 completions. And if we do k get pods, we see 5 pods. None of them are running, and all of them are in completed stats. So it's just that easy to set up jobs in Kubernetes and have them run, and just a couple more parameters and you can have them running in parallel. So now that we have that, let's have a look at scheduled jobs, also known as cron jobs. Alright, so I'm back into the code editor here, and here's an example cron job that we can create. The syntax here is very similar to the jobs that we just created, but a few key differences is the top here. The API version is actually different. In our jobs, it was batch/v1, but for cron jobs, we're going to use batch/v1 beta 1, since cron jobs are a newly introduced feature to Kubernetes. Anyways, we got a name here, and I've just given a descriptive name saying that this batch job is going to run every 15 minutes, and we have a schedule here specifying that. So this works the exact same as regular Linux cron jobs. The first parameter is minutes, then we have hours, days, weeks, months. So the stars specify to run of every hour, of every day, of every week, of every month, and in 15-minute increments. So if you need a refresher of how cron jobs look, just Google it, and you can make the schedule anything that matches the cron standard. And the next thing is just using a template of a pod, and this is the same one as our regular batch jobs. Let's go ahead and create this cron job, and then we'll have a look just to make sure that the pods have been run every 15 minutes. So clear the screen, and we'll just do create-f and name it cronjob.yaml. Hit enter, and we can see that it's been created. And if we want to see this, we don't do kget jobs, we actually do kget cronjobs, which makes complete sense. And in there you can see the name as well as the schedule. So this is going to run every 15 minutes. If I do a date, we can see that it's going to run in about 6 minutes from now. So I'll go ahead and pause the video, go grab myself a refreshment. We'll come back and check and make sure that this automatically started. Alright, I hope everyone grabbed a refreshment of their choice. We're back in the shell here, and this batch job should have run. So if I refresh this, I can see that the last scheduled job ran 3 minutes and 41 seconds ago. And that matches up to the time and date I have here. And if I do kget pods, I should see that cron job. Here it is. And it's here, and you can see that it's completed. So it's that simple to schedule a cron job. So if you have like a Python script that needs to run once a night, maybe like a backup or something, a cron job run from Kubernetes is the perfect way to do that. Alright, so now we're going to go on how we can have a look at what's happening in our Kubernetes system by using the Events command. And this command is really good for troubleshooting. It shows you exactly what's happening within your Kubernetes cluster. It shows you all the pods coming up, all the services, all the jobs that are scheduled. So if you ever need to troubleshoot, see what's happening with these pods, see if they're coming online, this is the command to use. So it's as simple as just going kubectl get events, and this is going to bring a list of events here, and you can see that I restarted my system about 15 minutes ago, so it looks like the kubelet service and Minikube services started, and then it started to bring up all my pods. If we have a look at what I was doing yesterday, it looks like the system was just sitting idle, and the scheduled job was set to run every 15 minutes or so. So yeah, just this one command gives me all the information I would need to know on what's happened with the Kubernetes system. And of course, all this information can be sent to a third-party logging server, but we won't go over that in this course. We just want to know how we can pull this information directly off of the Kubernetes server. So the next command that you might want to use when working with Kubernetes events is just to add the -w parameter. And what this does is it monitors it in real time. So you could have a terminal open and just run this command and just leave it open, and you could watch the events start up in real time if you're starting pods or anything like that. So it's really good for real-time troubleshooting. Our system doesn't really change much unless we go in there and start up a new pod, so not that interesting for us, but in a live production server, you'll probably want to use the -w parameter. And the next thing is, you might want to filter on namespaces. So by default, when we do the kget events, it's just pulling all the events from the default namespaces. But if we go kget ns, this will return all our namespaces. and say we want to see what's happening in the kube system. This, of course, is the Kubernetes internal services that are used to run the entire Kubernetes infrastructure. So they're very important services. Let's see if we can have a look at the events just to give us a better idea of what this kube system does in the background. So to do that, we would just do get events, and then we're going to filter on the namespace, and I'll paste that in. And you can see that it's returned all the events that happened in the kube system namespace. So as you can see, it's doing some stuff in the background. We're not too interested on what exactly it's doing here. It's just good to know that that information is available to you if you ever need to do some sort of troubleshooting on the back end of Kubernetes. But yeah, that's it. That's all I want to show for events. In future videos or later on in this course, we might run a few more event commands. But that's all you really need to know for the basics of events. Alright, so the next topic we're going to cover here is services and how you can create services to direct traffic to pods. So previously we've been creating pods, but every time we've interacted with the pod, we've been sending the traffic directly to the pod's IP address. So for example, we've been creating a web server and we've been using the curl command on the pod's IP address to connect to that web server. However, you can see from this diagram that wouldn't be the best way to do it. We have pod A in this diagram, and there's 3 different replicas of pod A. This is a 2-node cluster, and pod A has 2 instances on the first node and a 3rd instance on the 2nd node. So ideally, to resolve this problem, we would have the user or client connect to a service, and that service would load balance the traffic between the pods. So all we need to do that is add a service. So it's as simple as this. The user, the client, connects to the service, and the service load balances that connection over to the pods. So I think this is a pretty simple concept to understand why we would want to use a service instead of having clients send their traffic directly to the pods. So let's pull up our code editor and we'll start configuring our service. Okay, so we have a newly created YAML file here, and I've named it mypod-service.yaml. Let's go ahead and configure a service here. So the first line is always the API version, and services were introduced with the release of Kubernetes, so version 1 will work for us here. Next we'll specify the kind of Kubernetes resource, which will be a service. After that we want to specify the metadata. After that, we want to set the spec. Within the spec, we want to specify the ports that are going to be mapped. So we'll say ports, then the port, we'll put 80. And just to match the YAML formatting, I actually need to do a dash here. Underneath that, I'll put the target port. And the target port isn't indented right, so let me indent that. The target port here, though, is going to be 8080. And just to explain this quickly, port 80 is the service port, so this is what the client's going to connect to. And the target port is the port that the container in the pod is listening on. So 8080 is what we have set up with our current pod. So that's pretty good so far. But you're probably wondering, how does this service know which pods to map to? And the best way to do that is through the selector. So let's have a look at our current environment. I'll pull up the terminal here. And if I do get pods, I can see I got a bunch of pods here. And if I wanted to use these 3 pods, which are controlled by my replication controller, then I would need to know which labels they use. So let's rerun this. And let's see what the value is for the app label that I have set for them. So I've got all my pods returned here. I can see these 3 pods all have the same app label, and that app label is my pod. So if we hop back into the code editor, let's use our selector now. And within the selector, we're going to say match on app, and the value needs to be my pod. And this should be enough to get our service up and running. It's going to map port 80 to port 8080, and it'll send the traffic to all pods that have the label of app my pod. So to actually create this service, let's clear the screen, and then let's go k create -f, and it was called mypod-service.yaml. Hit enter. We can see the service was created. If we do a k get service, or if we do k get svc, we can see that pod service was created, and this is the IP address. If we go ahead and curl that, we should see some traffic returned. So we can see we got some return traffic here, and it looks like mypod-4j9rx returned. Let's have a look at our pods here, and yes, that's one that we expected. And if we keep running the curl command, we can see, okay, ccdcr returned it this time, and if we do it again, 65bwd. So we can see the service is sending the traffic successfully to the pod, and it's load balancing all that traffic. If we wanted to get more information on this service, we could do a k describe service, and then specify the service name, which was pod service. And there you can see that it returns all the information that we would need. You can see how it's selecting the pods. You can see the IP and port that our clients would connect to. You can see the endpoints that are receiving the traffic. So these are our 3 pods. And then there's this other variable here called session affinity. And basically what this means is the connection sticky? For example, if the same client keeps coming back to the service, do you want it to always go to the same pod? Or do you not care and it's fine that it gets load balanced between all 3 pods? If session affinity is set to none, then it's just going to load balance by default. But if you have session affinity turned on, it's going to make the connection sticky, and it's always going to go back to the same pod. So let's go ahead and see if we can turn that on just to verify that it's working. If we hop back into our code editor, all we need to do is add an extra line here under spec, and then we're going to set the session affinity. Now there's a few different options you can choose for session affinity, but what we're going to put here is client IP address. That way, when the service sees the same client IP come in, it's going to determine if it already has a session for that client, and if it does, it's always going to send the client to that same pod. So we have this saved. Let's go ahead and apply the changes to our service. So we'll do a k update -f. And it's not update, it's actually apply. And we can see that the service was configured. If we do a k describe service pod service, we can see that the session affinity is now set. Now if we curl the IP address, we should see it always return the same host name. So let's try that. Hostname 65bwd. Let me add a grep to this. So let's say hostname. Now you can see I've ran the curl command several times, and the pod that always comes back is 65bwb. And that's because that session affinity has been turned on. So I'm going to clear the screen here. And another really good command when working with services is the k get endpoints. And basically what this does is it gives a quick summary of the service name and the endpoints attached to that service. And if you need any additional information, you can go k describe endpoints. And from that you can see we got pod service here, and then within that we have all the endpoints that are attached to it. Another thing I want to go over when discussing services is, of course, using IP addresses is something you don't want your end users to use. They want to use DNS. And Kubernetes has its own built-in DNS, so there's name resolution built in here. So if I do kget service again, we can see that pod service is the name, but we've been using the cluster IP to get to the service, right? So we did the curl, and then we put in the cluster IP. However, if you're an end user, it's unlikely you're putting in the IP address of where you want to go. You're probably putting in a host name. So if we wanted to get to the hostname of this service, there's actually name resolution already in place. And I'll show that by connecting to one of my other containers and doing some name resolution. So the first thing I'm going to show here is if I do kget pods. And I'm going to have a deeper look into my pod here, just to show you how Kubernetes injects configuration into pods. So I'm going to do a kexec, and then put in the pod name. And I'll do --env. And you can see Kubernetes has injected a lot of environment variables here. Now we're not going to bother going over what each and every one of these environment variables does, but it's just good to know that Kubernetes injects settings using environment variables and other things like that. Later on in this course, I'll show you how we can inject our own environment variables into pods and containers. But for now, it's just good to know that they're there. In regards to DNS and name resolution, we can check to see that Kubernetes is injecting name resolution into the container, and we'll do that by doing a cat, and then we're going to look at the resolve file. So it's resolve.conf. And basically what this file does on a Linux system, it specifies DNS settings. So it looks like there's 3 lines in this configuration, and the first line is setting the name server, and that IP address that it's using is the same IP address that we get when we do a kget service. And we can see that it matches up with this one, the 10.96.0.1, and that's the base Kubernetes service. So we know that this Kubernetes service is providing DNS name resolution. There's also the default search spaces there. And basically what this means is you can put in the service name without specifying default.svc.cluster.local. But the important thing to take away from all this is that there's name resolution built in. So we can easily test that. I'm going to run a command here from the pod. I'm going to do a curl, and I'm going to curl on this pod service just to make sure that that's working. And we see that it returns the web traffic. But if we run that command again, and instead of specifying the IP address, let's specify pod svc. And we can see that we got return traffic, so name resolution must be working. If we look into the details of what was returned, we can see that it returns all the web headers and everything. And we can see that, oh, this is the URL that it requested. It went to pod service port 8080, and specifying 8080 because that's the port that the container's listening on. Even though we went to port 80 on the service is forwarding it to 8080 on the container. Hopefully that makes sense to you guys. And I think that's all we really need to discuss about services for now. In this next section, we're going to jump into persistent volumes, which I think is one of the most important things to know when you're containerizing applications, since persistent storage is basically a requirement for any application that uses a database or storage of any type. So let's jump into that next section. Alright, so the next concept we're going to cover here is persistent storage. And getting persistent storage is really easy to do, and it's something you're going to almost always going to require when you're creating applications in pods. The best example I can think of is a database. You want a volume where you can store all that data, and you want to make it so if your pod gets deleted or something happens with your pod, you want that data to persist, and you want it to always be available. So, up on the screen, I have a very simple pod configuration that runs MongoDB. As you can see, it's very similar to the pods we've created before, and it's just using the default MongoDB image, which it's pulling from Docker Hub. And right now, we do not have persistent storage set up. So let's go ahead and get this up, and we'll see how useful this database is without persistent storage. So we're in the command line here, and all we need to do to create that MongoDB is do kcreate and use the file MongoDB, and this will create the MongoDB. If we go kexec -it, and then specify the pod name of MongoDB, we can send the command mongo, and this is how you interact with a Mongo database. So we can see that we're in the MongoDB right now, and MongoDB is very simplified NoSQL database. So it's very easy to just create a new database and just start inserting data to it. So let's do that. I'm going to create a database just by doing use mydb, and it switched to the database mydb. And if I do a db.test.insert, and then let's make sure I got the syntax right. I'm actually going to paste this in just to make it easier. This is available on the GitHub if you want to just copy and paste these commands. But you can see that we did an insert, and we set the insert name to be test. Now if we do a db.test.find, we can see that it found the object. Perfect. If we exit out and go back in, we can see we can find that data. Switch to the database first, then do a db.test.find. So our data is there. It seems like it's persistent, but if we go out again and say something happens to that pod, like someone accidentally deletes it, so we've quote-unquote accidentally deleted the pod. Let's recreate it and see if the data's there. So I'll just do a kcreate -f and then specify MongoDB. Then I'm going to do kexec it MongoDB. Specify the command mongo. Now I want to use mydb because that's the one I created before. And if I try to find the data that I've inserted, I can see it's not there. So we can see that there's a problem with data persistency. So this database application that we created isn't very useful until we introduce volumes. So it's very simple to do. Let's hop back into the configuration, and all we need to do is specify this container to use a volume. So I'm going to go down to the next line here, and it's an attribute within the container. So I'll specify volumes. The volume's going to require a name. So I'll call mine MongoDB-data. And then it needs a mount path. And this is the path within the container that it's going to store the data and work with the data. So we have the volume set within the container, but now we need to set up the volume on the host system. So we do that under the spec. So we're going to specify volumes. Then we're going to specify name. And we want it to match this name here, since our container is going to be referencing this point. After that, we want to specify the host path. And this is the path on the node that is hosting the pod. So I'm going to specify /data/db/mydb1, but you can make this path anything you want it to be. And also, if you have a NAS available or SAN or anything like that, you can map it to something like that. And that's a much better solution if you have multiple nodes and you don't know which node this pod's going to come up on. You want it to be on a network location. But in our example, we're just going to use a local path. And then at the bottom here, we're going to specify a type. Now, there's a lot of different types, and we'll probably use a couple different ones, but the type we're going to use for this example is a directory or create. And basically, this is saying use a directory path, and if that directory path doesn't exist, create it. So that looks good to me. It actually doesn't like the indentation here. Let me fix that. Okay. and just make sure, if you're following along, that your indentation matches up. I highly recommend using a code editor that recognizes YAML formatting. That way it gives you these little chevrons where you can minimize and maximize things, and you can see how things are grouped together. So under spec, you can see spec has containers as well as volumes, and then within the volumes you have all these attributes. Within the containers you have the container information. So make sure you're using a YAML editor if you're following along. So this looks good to me. Let's go ahead and recreate the pod and see if inserting that data makes a difference. So we're back in here. Let's do a kdelete MongoDB. Oh, we need to specify pod. So there we go, kdelete pod MongoDB. You can see it's been deleted. Now let's do a kcreate f MongoDB. And it doesn't like something here in the container. Let's have a look. And it doesn't like the volumes in the container. I may have specified that wrong. Okay. Yeah, this isn't supposed to be volumes. It's actually supposed to be volume mounts. Sorry about that, if you're following along. It should be volume mounts, and then at the bottom we specify volumes. Okay, let's hop back in. And go ahead and create it. We can see it's been created. And if we connect to it now, looks like we're connected. Let's do use MyDB. I'm going to paste in the insert. Make sure I can find the data. Exit out. Now let's delete the pod. And before we actually recreate this pod, we should be able to see that there's data on the host system. So let's go look for that data. I'll pull this back up here. So looking at the configuration, the host path for the data is specified as here. So let's see if we can get there. I'll do an ls. And we can see, yeah, let's actually clean up that output. So yeah, we can see there's a bunch of files there. It's obviously done something. It's storing the data, so this is a good sign. Let's bring the pod back up and see if it can actually retrieve the data now. So we'll recreate the pod. And then we'll hop back in. I got a little error there. I had to retry. I just tried to hop into it too quickly. I guess it takes a couple of seconds to initialize, but we're back in. So we'll do use MyDB. And then let's just try to find, and we can see that we can find the data that we created. So it didn't matter that we stopped the pod, we killed the pod, and then we recreated it. The data's still there because the volume's being stored on the host right now. So yeah, like I mentioned, there's tons of different options for volumes. If you go to the Kubernetes website, you can see all your different options. The configuration of all different types is very similar to the way I just did it. But yeah, you have tons of options of doing network paths or anything you need for your environment. So that's the basics with storage volumes. And that's all the information you really need to know to get started with Kubernetes. I hope this video course was helpful. Again, if you haven't checked out the Kubernetes website, you can see I'm on it right now, and it has all the information available, all the concepts that we went over in this course. I would dive into this, review everything we went over, and that should give you a good understanding of the base components of Kubernetes. I will be releasing a more advanced course where we go over more advanced topics and build more complicated, more advanced pods and applications. But I didn't want to overbloat this course. I just put in all the concepts that I think everyone needs to do sort of a basic setup of Kubernetes and basic administration of it. So please, if you have any questions or comments, please leave them below. If you have any requests for videos in the future in regards to Kubernetes, please let me know, and I'll do a video on one of those concepts. Other than that, if you enjoyed the video, please hit the like button, and if you want to see more content like this, please subscribe. Thank you so much, and I hope you enjoy your journey with Kubernetes.